Hi everyone! Today we're going to continue to learn about earth sciences and asking the question, why does the earth look the way it does? We have done some experiments already and learned that some processes are slow and some are fast. Look at the following pictures and think about how this happened. Why does it look the way it does? Looking at these images, some were obvious how the physical weathering happened. And did you see the pictures? What do you think happened? Well, the answer to why they look the way they do is weathering. In particular, physical weathering. Looking at these images, some were obvious how the physical weathering happened and some were not as obvious. We're going to do two experiments today that will go over the concept of physical weathering. Now, I just have to remind you that physical weathering is something that happens over many, many, many years, millions of years. It's not something that happens overnight or even in a week. It takes a long time. The lab that we're going to do today is more a model of what is happening in nature, in the real world, because it's kind of hard to watch weathering and to observe nature over that period of time. So let's see what happens in our model. For this lab, I will be using plaster of Paris. I will need 2 small plastic cups, 2 large plastic cups, 2 plastic spoons, water, 2 balloons, and some tape. Before we get started, I wanted to show you what plaster of Paris is. Plaster of Paris is made out of gypsum. Now this is the softest mineral that there is, and it's a powder at the moment. It is a solid. When mixed with water, it will turn into a solid. And plaster of Paris is what they use to make the drywall. Your walls are made out of plaster. We'll watch and see how this works. Now I'm going to make my own rock using plaster. The first thing I'm going to do is take my 2 balloons. One is going to get filled with water and one is going to be filled with air. I have my 2 balloons, about the same size. This is filled with air, you can see, and this one is filled with water. What I want to do for this lab is model what happens when water freezes inside of a rock. I have 2 plastic cups. I'm going to invert them. I'm going to poke a hole at the bottom, poke a hole inside the other. Using a wooden skewer, I'm going to make my hole a little bit bigger. Now I have a hole at the bottom of my cup and my second cup. And now what I want to do is place these balloons inside of the cups like so. Now I just used a paper clip to fish these balloons in at the end and this way as well. Now I have 2 balloons inside of a cup and I'm going to tape the bottoms down to make sure that the balloons don't go anywhere. What I'm doing here is I have a balloon that has, I'm going to have a rock that's going to have air trapped inside of it and a rock that has water trapped inside of it. Now the water is trapped and it can't escape because it's in the balloon. And I'm going to tape my balloon down. Both sides. Just making sure that my balloon does not go anywhere. And then I'm going to label my balloon. On the bottom of this one, I'm just going to put a W. And this one, I'm going to put an A for air, and the W is for water. Now what I'm going to do is mix my plaster of Paris, my gypsum, with water and pour it onto these balloons and fill my entire cup with them. And remember what I told you, it will harden. As soon as it mixes with water, it will harden. So I'm going to take 2 cups of plaster and I'm going to mix that with 3 cups of water. What do you notice happening here? A little bit of bubbling. So the pockets of air escaping. I'm going to mix and mix. You can see it turning hard already. I'm going to add another cup in slowly. And mix, mix, mix. And I think I have the right consistency. I'm not going to add my 3rd cup of water. It looks like it's about right. And now I'm going to bring my cups over. And now I'm going to pour my plaster of Paris into my cup all the way to the top. And I'm going to do the same for the 2nd cup. And I'm just going to wait until these harden. It should take maybe about 10-15 minutes. Now while these 2 cups are hardening, while the plaster is hardening, let's talk about what we did and the purpose. I had 2 balloons. I filled one with air and one with water. I stuck it down in there and I kind of molded my rock around the balloon with air and the balloon with water. This is a model. I'm modeling how air can get trapped inside of rocks, so can water. How does water get trapped inside of a rock? Well, if there are air bubbles inside of them, and then it rains, that water will displace the air. It will move the air out. It will kick the air out, and then the water will stay there. Now remember, this is just a model of physical weathering. We're building a rock that has air trapped in it and a rock that has water trapped in it. Now let's talk about what happens if the weather changes. If the weather's hot, well, the water will stay a liquid, or if it's really hot, the water will evaporate. Not in my balloon because it's trapped, but in a real rock. But what if we have really, really cold weather? What if we have freezing weather? What happens to water as it freezes? Water turns into ice as it gets cold. As water freezes, it actually expands. Frozen water takes up more space than liquid water for the same exact amount. You can try this, maybe you have before, if you've taken a water bottle, plastic water bottle, disposable ones, and you have filled them with water and put them inside of the freezer. If you leave it in there too long and wait for all of it to freeze, what happens to that water bottle? Try that. It's a fun experiment. What we're going to do now is, once these harden, I'm going to place them in the freezer and then come back and investigate. But I want you to look at them now. What do you expect these to look like? Right now, it's going to be, it looks smooth all around. Looks perfectly even. Looks like the rock is going to take the shape of my cup. Are both of these cups going to look exactly the same? We talked about water freezing and water expanding as it freezes. Does air expand as it freezes? We've learned about that before in previous lessons, but make a prediction on your sheets what you think will happen. Now, water freezing inside of a rock is one type of weathering, but there's so many other different types of weathering. Weathering can happen by rocks hitting one another. Weathering can happen by water hitting a rock. Physical weathering can happen even by air, by wind blowing on the rocks. For this lab, you will need 3 whole sugar cubes, 2 rocks, water, a dark surface, and a plastic or a glass jar. For the first part, we're going to see how water can weather rocks. Now I have a sugar cube that represents my rock. Make a prediction. What do you think will happen once we add water to this rock? Go ahead and pause this video. Make your prediction. I'm going to use my pipette to add water to my rock. Let's see what happened to our sugar cube. Started out looking like this. With just a little bit of water, it has now physically changed. It is broken up. You can see the middle is hollow. I can pick it up. It breaks up into 2 pieces, and it's not as strong as it was before. What do you think will happen if I keep adding water? Well, completely dissolve away and turn into tiny, tiny little granules. We can't see the granules right now because they've dissolved in the water. But you can imagine once that water evaporates, we'd have sugar crystals, kind of like sand particles. Go ahead, do this lab and make your own observations. For this next lab, you will need 2 sugar cubes, 2 pieces of rock, and any jar will do. Now, it's a good thing to take note of the size and the shape of your sugar cubes. And what we're going to do is you're going to take your sugar cubes and you're going to drop them in along with your rocks. Now, for this part, you are going to need the help of a clock because you are going to weather these rocks for a total of 10 minutes by checking them every 2 minutes. So the way we're going to weather today is going to be by shaking. Now what you want to do is when you're shaking, you want to shake at the same rate, at the same speed, the entire time. So let's go ahead, make your prediction. What do you think will happen to the sugar cubes that are inside of the jar after 10 minutes time? Start shaking. Let's see what our rocks look like after 2 minutes. What you're going to do is find a dark surface and pour out. Wow. Look at what happened to my sugar cubes. They have turned into sand. There's still 2 pieces. Are they just as big as before? No, they're smaller, and the shape has changed too. Do this for every 2 minutes, for 10 minutes, and we'll come back in 10 minutes and see what happened. Let's take a look at 6 minutes and see if we've had more progress. Oh, look at that. My 2 rocks broke into 3 rocks. We even weathered our big strong rocks. And our sugar cubes are even smaller. And we have created even more sand. I'm gonna put it back in here and weather it for another 4 minutes. Now that 10 minutes have passed, let's take a look again at our sugar cubes and rocks. So here is one rock. Here is another rock. And my 1 rock broke into 2. And this is all that I have left of my sugar cubes. But look at all this sand or powdered sugar that we've just created. Now just for comparison, look at how they started. And after 10 minutes, look how much weathering has happened. I'm going to take these off because these were not part of our focus. But go ahead, do this lab and record your observations. Now let's come back and visit our plaster that we've created. You can see it is now hard, it is no longer soft. There's a little bit of water left at the top, which is fine, but completely hard. Let's look all around, see, make an observation. We see some tiny, tiny air bubbles that are in there. And let's look at the other one. Oh, again, oh, this one's hard. But now these are going to go into the freezer for 24 hours. And then I will bring them back and we will observe them again. Now let's look at our results. Here are my 2 cups that I had poured plaster over and I placed in the freezer. The letter A is for air and the letter W is for water. Let's observe the air.
Does it look any different? Tiny air bubbles like we had before, but it looks like it's perfectly smooth. Let's observe our water. Oh, wow, look at that. Cracks all over the place, all around. Look at all of these cracks. Where did these cracks come from? How come one looks so smooth and one is all cracked? The one with air looks like it's perfectly smooth. Down here you may see some tape. I just removed the tape so that we could see it a little bit better, but that's on the outside, not the inside. But look at this. So many cracks. Kind of reminds me of the cracks I see in a sidewalk. Let's talk about what happened here.
Now let's talk about what we did here. We had 2 cups, and these 2 cups both had balloons inside of them. One had a balloon filled with water, and one had a balloon filled with air. Now again, we are just modeling a rock that has an air pocket trapped inside of it, and another rock that has water trapped inside of it. We put both of these cups in the freezer, and we came back to see what happened. The air cup looks like nothing has happened. The air also got cooler inside of this cup, but it didn't affect the rock. What happened as the water in here cooled down? The water, the liquid water, turned into solid water, which is ice. Now water has a cool property that as water freezes, it expands. It takes up more space. As the water froze, it needed more space. So it only had one place to go, and that was to push the rock open. It had to break the rock apart. That's why it's broken here. Now what about air that's in here? What happens to air as it freezes? Air and most other substances, except for water-containing substances, air actually contracts. It actually becomes smaller when it freezes. It expands when it becomes hotter, which is fine because air can just escape, whether it's hot or cool, it doesn't matter. But the water expands as it freezes, breaking the rock.
Let's visit our picture again. Physical weathering can also be caused by trees and plants and their roots. Like you see in this picture here, it's caused a crack in the sidewalk, and it has caused breakage in the rock. Here's another picture, and in this picture you can actually see water that has frozen into ice, and it has been trapped inside of the rock, and once it froze, it caused all of these rocks to break. Here's a cartoon diagram of what happens when water collects inside of a rock crack. You'll see steps 1 through 4. Step 2, the water freezes, expands, forcing the crack to widen. The ice thaws and it contracts, and water gets deeper into the cracks again, and repeated extraction and contraction causes further cracks till rock splits apart completely. If we were to investigate our rocks again, we only froze them once. We could try refreezing and seeing if the cracks keep getting bigger and bigger.
I really like these labs because we can see physical weathering happening really fast, even though in the real world it does take a lot longer. What I want you to do is look around you on your walks or on your drives and see if you see any evidence of physical weathering on your sidewalks, on buildings, and take note of that. Good luck with the experiment.